All right, so what I'm going to have you do is try out angle measurements. Now this activity, if you print out your paper and you have a protractor, you can go ahead and try that out and finding these measurements by hand. But I'm going to assume we all don't have protractors, so let's even just kind of see some properties that come through based on the structure of this. So what I'm going to do is actually give you some of these measurements. This angle that's defined right here, we're going to have that be 30 degrees. And then also for this first picture, I'm just going to throw in this symbol right here. So then we'll know we have this 90-degree angle. And then for the picture to the right-hand side, for that angle that I defined there, if you have a protractor and your paper printed, that should come out to be 45 degrees. So let's talk about how we could solve for these unknown measurements. Specifically in this first picture, I want to find out what is this measurement here. Now when you're working with an image with multiple angles, like the 30 degrees, you give one line, and then if you want a different angle measurement, then you usually go 2 lines. If we had a different angle, you'd start going 3 lines, so you could just kind of layer them. It's like on the picture on the right, I have that 45 degrees, and then I want to look at this other angle measurement and try to find out what that is based on what the picture is showing us. So with this first one, we can think about this kind of larger angle here, that's our 90 degrees. And that 90 degrees has been cut up with this kind of middle line here. It made this smaller angle of 30 degrees, and then we have this larger angle. So what we could do is just with a little simple algebra is if all of that's supposed to be 90 degrees, all we need to do is think about taking out that 30 degrees that we already know. And what that'll leave us with is this 60-degree angle. Now this case here of having these 2 smaller angles and they're adding up to 90 degrees, this is called complementary. These are complementary angles because they add up to 90 degrees. So it's this special case of having multiple angles. But the key is that at the outside of everything is this 90-degree angle, and it's just been cut up by an extra line. So I could draw a line here, or there. No matter where I draw that line, I'll have complementary angles because they're both part of this larger 90 degrees. Now this picture on the right-hand side, kind of a similar idea, but in this kind of larger scale, is that we have this straight line that they're adding up to, meaning they're adding up to a straight angle, which means overall we have this 180 degrees. We can see 45 degrees of that has been taken up, and we just want to figure out what's left over. So with this, what we would do for calculation is take that 180 degrees, take out the 45, and that should leave us with this measurement of 135 degrees. And also a good thing to double check is like that picture looks like an obtuse angle. Make sure in terms of calculation, we are getting an obtuse angle out. If it looks acute, it should be below 90. If it looks obtuse, it should be over 90. This right here is supplementary angles. So it's when we have angles that add up to 180 degrees. So with this, it's the idea in terms of larger scale. We have a straight angle, some vertex, but then we have this other line coming through, and no matter where it's landing, it's just that those 2 angles are always adding up to 180 degrees. So we can use that property to solve for unknown ones. All right, so that's complementary and supplementary angles there. Now, what I want to talk about are some extra properties that come through with angles. And again, if you have a protractor, it can be a nice activity to practice that measurement if you haven't used it before. But again, I'll assume you don't have one, and I'll just give you some angle measurements here. This angle right here on the picture would be 128 degrees. And this angle measurement over here should be about 52 degrees. Now, if you do this by hand, you might have a slight difference. I mean, that's a theme among measurement with protractors and rulers. When you're trying to get specific with measurements, we might all get slightly different answers just based on human error, but it should be close by to those two numbers. Now, something that I want us to see, if I kind of zoom into just the intersections up here, I could keep measuring with a protractor and getting values out, but what would happen is you would notice a theme start to occur. Like if I went to get this angle measurement right here, it should be exactly the same. And if I measure over here, exactly the same as over there. This property here is the property of vertical angles, and it happens when you have two lines intersecting with each other. No matter how they're intersecting, it's a little property I want us to get down here. No matter how those two lines intersect with each other, you're going to get these pairs of vertical angles that'll have the same measurements. So if I choose this angle here, and that angle has some measurement, then vertical from it or across the intersection over here, that would have the same measurement. Similarly, if I looked at this angle here, this obtuse angle, whatever measurement that has, if I look across the way, that has the same measurement. So this can be a nice tool, like say we knew the angle measurement over here. Well, you have these supplementary angles, so you could find the blue angle pretty easily using that they add up to 180, and then you could fill in the blanks for the other two following that. So with this property, it can help you solve for a lot more angles just by giving you that single angle. Now, to kind of jump ahead in these definitions, I'm going to go to this definition of parallel lines because it's going to help us get other measurements out from this picture. What we want to notice is that this line KL up here is parallel to this line MN down here. Now, parallel means that if I continued those lines on forever and ever and ever and ever, infinitely, they would never intersect with each other. They would keep running, and use the term parallel, and that they'll never intersect. So for definition down here, for parallel lines, it's having two lines that never intersect. Now, in terms of notation, like say I did call this KL, and this one MN. For notation, what I could do is take line KL and line MN, and if I wanted notation to say that they're parallel to each other, you'd use a symbol of basically two vertical parallel lines between the notation there. Another way that two lines can work together is perpendicular lines, and it's when you have two lines that intersect with each other. When they intersect, they make a perfect 90-degree angle. So this would be two lines that intersect at a 90-degree angle. So with this, like say this was KL and this was MN, for notation, it would look pretty similar, but what we'd use is a different notation since perpendicular is very different from parallel. And for perpendicular, you would just draw something like that, these two perpendicular lines. So what's important up here is that we have these two parallel lines, and why that's important is because then with how this line IJ is occurring, if we have two lines that are parallel that intersect, it's going to bring through the same angle measurements that we're seeing. So what we would have down here is this angle right here would also be 128 degrees. And then based on that property of vertical angles, this would also be 128 degrees. And then that would force this to be 52 degrees because of our supplementary angles, which means this would have to be 52 degrees based on vertical angles and supplementary angles. So what you can see is when you have this line being intersected by parallel lines, we get all of these pairs and these same angles coming through. And that really overall in this whole picture, there's 2 angle measurements, 128 and 52. So some other properties that come through when we have this scenario is alternate interior angles. So if I draw a picture for some line being intersected by 2 parallel lines, alternate interior, so the interior part of the picture is in here. So that's going to be the interior of our intersections. And alternate interior means, like, say we focus on this angle here, it's that if we go to the other intersection and on the opposite side, that measurement's going to be the same. Similarly, if we were looking at this measurement here, if we go to the other intersection and on the opposite side, that would be the same. So where that's showing up in our picture up above here is if I focus on the inside and I have, say, I'm looking at this 52 degrees, I also have 52 degrees on the opposite side, but in the interior. Same thing with 128, it's the interior and on the right-hand side, which means interior on the left-hand side would have the same measurement. Another way that common angles come through with this, if we have a line being intersected by 2 parallel lines, alternate exterior angles. So that's where we're focusing on the outside here and the outside. So alternate exterior is, say I'm on the left-hand side up here. If I go to the right-hand side at the exterior, same measurement. If I was on the right-hand side up here, it means the left-hand side down below would be the same. So seeing that in our picture up above here, that would be like looking at this 128 degrees at the top here, on the left-hand side on the outside, right-hand side of the outside would be the same. And right-hand side of outside up here, left-hand side of outside there. So at the exterior of the intersections, the opposite sides match up. And then the last piece here is corresponding angles, which for these cases, there are a lot of corresponding angles, but it's basically when you have these 2 intersections where values occur at the same spot, you kind of look at where they line up, and that would be your corresponding angles. So say I'm on the upper left-hand side here, upper left-hand side, same measurement. Lower left-hand side will be the same as lower left-hand side. Upper right-hand side, same as upper right-hand side. And lower right-hand side, same as lower right-hand side. So we end up with these 4 pairs of corresponding angles. So seeing that show up in our picture up above here, it would be like looking at our 128 in the upper left, 128 in the upper left, 52 in the lower left, upper right, lower right, lower right. So it's just using how they line up with each other, and those measurements will be the same. So there are some definitions in how to measure angles.